Previously, when we learned about determinants of demand, we we know that when the income goes up, the demand goes up when it is a normal good. And when we learn about the law of demand, for example, we also learned that when the price goes up, the demand comes down. And when the price comes down, the demand goes up. So we did learn about some of the qualitative effect of a change in a determinant of demand. However, in a lot of applications in real life, it is important to know how much. Okay? So not only that it's important to know the direction, but it's also important to know how much. So that's what we're going to learn today. Okay? So we're going to learn elasticity. With elasticity, it allows us to analyze supply and demand with greater precision. Essentially, it measures how responsive buyers and sellers are to changes in market conditions. We're going to cover a few measures of elasticity in this course, but we're going to start with one of the most important one, the price elasticity of demand. The price elasticity of demand is a measure of how much the quantity demanded of a good responds to a change in the price of that good. So mathematically, it's a percentage change in quantity demanded divided by the percentage change in price. So let's look at an example. If the price of an ice cream cone increases from $2 to $2.20 and the amount you buy falls from 10 to 8 cones, then your elasticity of demand would be calculated as. So recall what you learned from your math class. How do you find percentage change in a variable? Okay, so refresh your memory a little bit. Recall what you learned in your math class, in high school or in college algebra. Okay? So let's take a pause for a few minutes so then you can work on the calculation. And then we'll come back. Let's take a pause. Okay, I'm sure some of you now have jogged your memory a little bit. Okay? And recall what you learned in your math class. To find any percentage change in a variable. So take for example, so in the numerator here, we want to find the percentage change in quantity demanded. So in math, is the new quantity minus the old quantity or the previous quantity divided by the previous quantity demanded. And because we want it in percentage, so strictly speaking, we want to multiply it by 100%. In the denominator, that's a percentage change in price. So in math, that's the new price minus the old price divided by the old price. And then once again, because you want it in percentage, so we multiply it by 100%. Okay? So that will give us the price elasticity of demand. Okay? And one thing in economics courses, a lot of times we use the notation E sub D or E sub P to denote price elasticity of demand. Okay? So with that, what was your answer? One more time. Okay? If you haven't done that before, if you haven't done that just now, let's do it now. Let's take a pause. It is very important that you actually are very, very proficient with the calculation. So let's practice. Okay, let's take a look at it. Because we're just beginning to cover these concepts, so I like to lay out all the information that is given. Okay, so it's easier, okay, to set up the question. Okay, so the initial quantity, that's 10 cones. The new quantity, that's 8 cones. The initial price, $2, and the new price, $2.20. So when you plug in all these numbers into the equation, percentage change in quantity, okay, that will give you negative 20%. If you're looking at a change and you have a negative sign, what that means is the quantity demanded decreases. And when you are looking at the percentage change in price, that's 10%. Okay, so what we have here is when the price increases by 10%, the quantity demanded drops by 20%. Okay, so let's plug in the equation to find the price elasticity of demand. Percentage change in quantity divided by percentage change in price. So that would give us negative 2. In this very specific examples, you have all the specific information. So you know it's because of 10% increase in the price that leads to a 20% decrease in the quantity. But assuming that, in other cases, that you're not given all these specifics. Instead, you're just told that the price elasticity of demand is negative 2. That's it. You don't have the detailed information. So when you look at a price elasticity of demand negative 2, so in general, what that means is every 1% increase in the price leads to 2% drop in the quantity demanded. By the same token, you can also say every 1% drop in the price leads to 2% increase in the quantity demanded. So we have a special name for this formula that we are used to in math class. So according to mathematical convention, okay, so that's how you find the percentage change in a variable. Okay, so here we call this point price elasticity of demand. So basically you just follow the mathematical convention to calculate the percentage change in each variable. Okay. It is what we are used to in math class, but it does have a shortcoming. This method, this point method, does have a shortcoming. Let's take a look at it. So let's go back to the same question here. Okay. But instead of raising the price, let's reverse the directions of change. Instead of raising the price, let's lower the price from 220 to 2. So it's exactly the same two sets of numbers, but the directions of change has been reversed. So let's drop the price from 220 to 2, and then accordingly, the quantity demanded increases from 8 to 10. Okay, so it's the same two sets of numbers, different directions of change. Okay, so by using the point method, which is the mathematical convention, let's see what we find. Okay, so now we have the initial quantity and the new quantity, okay, and the initial price and the new price. Okay, so when you plug in the numbers, okay, into each equations, you find that the percentage change in quantity is 25% and the percentage change in price is negative 9.09%. When you plug into the equation to find the price elasticity of demand, you find that the price elasticity of demand now is negative 2.75. So it's quite bizarre, right? I mean, it's the same two sets of numbers, But once you reverse the directions of change, you get two different numbers for price elasticity of demand, which is all right mathematically speaking. However, in business applications or economics applications, this may not come in too handily, because that means every time you change the price, you will need to redo the calculation. And also, a lot of times, all a business person wants to know is how price elastic a product is. It doesn't make sense to have two measures to measure the same sensitivity to the price. So as a result, in economics applications, whenever possible, we will try to use the midpoint method. Midpoint method, or sometimes called the ARC method, average rate of change. So midpoint method to find ARC price elastic demand is preferred whenever possible, okay? Because it gives the same direction regardless of the directions of the price change. Okay? So what is a midpoint method? So it's still the same. The percentage change in quantity demanded in the denominator divided by the percentage change in the price in the numerator. Okay? So the 100% you should, strictly speaking, we should have 100% here because we're looking for percentage change in both the numerator and the denominator. But because you know that when we have 100% in both the numerator and denominator, at the end, they will cancel out each other. So some of you would prefer to just drop that 100 percentages right away. But do bear in mind that even though you drop that 100%, you're still looking at a percentage. So if you get 0.25, for example, after you drop the 100%, 0.25, you have to bear in mind that you're looking at 25%, not 0.25%. Okay? So what is a midpoint method? So very similar to the point method, okay, with a slight difference. So let's look at this numerator. So is the difference between the two quantities divided by the midpoint of the two quantities. So instead of the initial quantity, we're dividing the difference between these two quantities by the average or midpoint of the two quantities. Okay? So Q2 plus Q1 divided by 2. Okay? In the denominator, we're looking at percentage change in price. So that's the difference between the prices divided by the midpoint of those two prices instead of the initial price. So let's come back to the same questions as before. Okay? If the price of an ice cream cone increases from $2 to $2.20 and the amount you buy falls from 10 to 8 cones, now let's find the elasticity of demand using the midpoint formula. So let's pause so that you can spend a few minutes working on this exercise, and then we'll come back. Once again, it is important that you get the practice you need to be proficient at this kind of calculation. So let's take a few minutes. Let's pause. Have you paused the video? Let's pause the video and work on the exercise. Okay, so once again, let's set up the question. The initial quantity, that's 10. The new quantity, that's 8 cones. Initial price, and then the new price. Okay, so Just give me a second. I'm going to go back to this. Okay, so percentage change in quantity using the midpoint method. So 8, the new quantity minus the old quantity divided by the average or midpoint between these two quantities. Okay? So when you do the calculation, you get 22.22%, negative 22.22%. So negative 2 divided by 9. Right? So percentage change in price using the midpoint method. So 100%, okay, multiplied by, well, the difference divided by the average of the two prices. Okay, so you get 9.52%. So that's 0.2 divided by $2.01 or 2.1. Okay, so that will give us, so you plug in the percentages in the equation to find the arc or the midpoint price elasticity of demand. So 9.52% increase in the price will lead to drop in quantity demanded by 22.22%. So that will give us negative 2.33 as a price elasticity of demand. Okay? So every 1% increase in the price will lead to 2.33% drop in the quantity demanded. Okay? So we are going to use midpoint method in economics courses or business applications whenever possible, because the answer remains the same regardless of the change, the directions of the change. If you don't believe me, you can reverse the change, reverse the directions of change. So instead of raising the price, let's lower the price. Okay? So you find that you get exactly the same answer.